Awesome. All right, so yeah, let's talk about Mac malware from 2016. We've got a lot of stuff, so I'm going to just dive right in. As Patrick mentioned, my name is also Patrick, and as he also mentioned as well, I've worked at a variety of acronymed places. I'm currently the Chief Security Researcher at COMMSEC. So briefly, COMMSEC does crowdsource vulnerability discovery with vetted security researchers. We basically have this external team of hackers, freelancers, researchers that find lots of bugs in our customers' IoT devices, network endpoints, and mobile apps. So if you're interested in basically getting paid to find pretty easy vulnerabilities, check out COMMSEC.com. All right, so again, I'm going to be talking about Mac malware from 2016. And just as a side note, all the samples or specimens I mentioned in this talk can be downloaded from objectivec.com. So if you're interested in playing around with some of these specimens, want to follow along, check those out. All right, so for each sample, we'll start by talking about its infection vector. That is, how does it get onto end users' machines? And we'll see that most of these actually require some sort of user interaction. So the user has to be tricked into clicking a fake pop-up or perhaps on an email attachment. Of course, the more sophisticated or advanced hackers are going to be using exploits, maybe 0 days. But luckily, most Mac malware, at least that's publicly been discovered recently, doesn't use such advanced techniques. We'll then talk about, for each specimen, its persistence techniques. And in the context of this presentation, persistence means the method that the malware uses to ensure that every time the system is rebooted or the user relogs in, that the malware is similarly or equally automatically executed by the operating system. I gave a talk about 2 years ago at RSA about 20 or so different techniques that malware could use on a Mac to gain persistence. But we'll see that the majority of Mac malware, both in 2016 and even years previous to that, pretty much used one of 3 techniques. So the most common is launch daemons and agents. And if you're familiar with Windows malware, this technique is essentially synonymous or similar to Windows services. So what you do is you basically create a property list file or a plist file, and you have the path of the binary that you want to execute. And then you can set various keys such as run at load set to true. And if that's specified, the operating system will automatically execute whatever program you specify. Other techniques include browser extensions and plugins. A lot of adware uses this technique. And then login items are another mechanism that applications or MacOs malware can use to persist and be automatically executed every time the user logs in. For each specimen, we'll also talk about its features or goals. We'll try to identify what was the malware created to do. Now, there's basically 2 main classes of malware. There's malware that's created by cyber criminals, and then there's malware that's created by nation states. So the malware that's created by cyber criminals is interested in pretty much money. So it's going to have features such as displaying advertising, perhaps ransoming your files, etc. While malware that's created by nation states is going to be more about gathering information, surveillance, those kind of things. So it's going to have capabilities like monitoring your webcam, possibly capturing key log strokes, etc., etc. Finally, for each specimen, we'll talk about how to remove it from your system. And we'll see most of these specimens are standalone, meaning they're not necessarily integrated or intertwined in an infected system. So pretty much you can just delete the binary and their persistence mechanism. Of course, though, it's a really good idea to always fully reinstall the operating system if you are infected, because obviously hackers or malware could always download other malware onto your system. So I always recommend people fully restore the operating system if they have a malware infection. All right, so let's dive in and start talking about some of the, or rather all of the specimens that appeared in 2016. So the first one was called Key Ranger. This was discovered by Palo Alto Networks in March, and it had the honor of being the first fully functional in the wild ransomware for macOS. So in terms of its infection vector, how could users be infected with this piece of ransomware? Well, it turns out the malware authors actually hacked the official website of a popular Mac BitTorrent application named Transmission. What they then did is they infected this application and injected their malicious ransomware into the application bundle. So then when an unsuspecting user would go to the legitimate Transmission website to get the BitTorrent application, instead of getting a pristine copy, they would actually get a copy that had been infected with Transmission. Now, the attackers actually re-signed the maliciously infected application. So even if the users had something like Gatekeeper enabled, which normally blocks unsigned code, it would bypass that because, again, the attackers had re-signed the application. So if we analyze KeyRanger's code, we can see what's going on. So we start by looking at the application bundle, specifically the info.plist file. And in this file is the path to the application or binary to execute when the users double click on that. It turns out it points to a binary called transmission. Not too surprising there. This is actually the legitimate transmission binary, but it's been modified. So if we look at the code at the beginning of its main function, we can see that they've injected some extra instructions. And what it does, these extra instructions, is grab a file called general.rtf from the applications bundle, save that as kernel_service, and then execute that. So if we look at this general.rtf file, as I mentioned, it's in the resource folder of the application bundle. It appears to be an RTF document, but if we run the file command on it or look at its hex bytes, we can see, no, it's not a document. It's really a mock-O binary executable. So if we disassemble it or take a closer look at it, we can see that, again, it's not a document, it's a binary, and it's been packed with UPX. UPX, though, is kind of a nice packer, or at least for malware analysts, because you can take a file that's packed with UPX, run it with UPX-D, and that will unpack the binary. So once it's unpacked, it's pretty easy to disassemble or analyze, and we can pretty much quickly see what it's doing. So it does pretty much two things. It encrypts all files that appear under /users, and then it looks for files that match certain file extensions under /volumes, so .jpegs, .documents. Now for every directory it creates an encrypted file in, it creates a plain text document that's called readme for decrypt. And if we look at what this readme for decrypt file has, it has instructions how to decrypt. So it's pretty standard ransomware, but again, it was the first fully functional in the wild ransomware that hit macOS, so kind of interesting. It's pretty easy to remove from your computer. You basically just delete the binary. As far as I know, there's no persistence mechanism for this piece of malware because, again, it's ransomware, so it doesn't really need to hang around. And of course, delete the infected transmission application as well. Okay, so the next sample I want to talk about is Eleanor, and this was discovered in July by Bitdefender. And as we'll see, it's a PHP-based backdoor that exposed infected computers as hidden Tor services. Now, in terms of its infection vector, it turns out that what the Mac malware authors did was essentially take over or recreate an abandoned application that was on macupdate.com. So there was this application called easy.converter that would legitimately allow you to convert documents. And I guess it was abandoned, so the malware authors created a new instance of this application that was just malware. As I mentioned, this was hosted on macupdate.com. So again, if legitimate users went to download what they thought was a converter application and ran it, they would have then become infected with this malware. Turns out it looks like the malware authors used a development tool called Platypus to create this Mac malware. Now, Platypus isn't a malicious tool. It's just basically what it allows you to do is take a script and convert it to a native Mac application, kind of like py-to-exe or something like that. This is important to understand because Platypus applications, when they're executed, run a bash script called script. And we can see that in the application bundle. So this is actually the malicious code, and since it's just a bash script, it's very easy to analyze, right? We don't have to decompile or disassemble it. We just can open it in a text editor. So when we do that, we can see it's persisting 3 different launch agents. Obviously, the malware authors really didn't care that much about stealth. So let's take a closer look at each of these 3 launch agents because each of them is a specific component of this malware. So the first launch agent creates a plist or properties file called com.getDropbox.integritycheck.plist. And this will execute a application or a binary named con, C-O-N-N. And what this binary does is sets up a hidden Tor service. And we'll see in a moment this exposes a interactive PHP backdoor. So we can examine some of the config files based on this Tor service, or use a tool like Task Explorer, which can show network connections, to understand how the Tor service is set up. So specifically, we can see there's a proxy and a control mechanism locally listening on port 9060 and 9061. Now, of course, the attacker needs to know about the hidden Tor service because it's going to be unique for each infection so that he or she can connect to it. So the second launch agent takes care of this. It's a binary, or rather a script called check hostname, and it does two simple tasks. What it does is it encrypts the name of the hidden Tor service and then publishes that to pastebin. This then means the attacker can go to pastebin, grab that encrypted service name, decrypt it, and then connect to the infected computer. The final launch agent that the binary or malware persists is called DBD. And if we look at it, it actually turns out to be Apple's signed copy of PHP. If we look at the property list that persists this binary, we can see it's executed with various command line parameters, including the S argument, which runs a built-in web server. So if we look at what it's serving up, we can see that it's a copy of an open source PHP shell. What this shell provides, a little hard to see, but it provides complete remote control over an infected computer. So it gives the attacker a remote shell, a file explorer, script interpreter, etc. Now, the malware was also distributed with two utilities, Netcat, which we all hopefully know what it is, and another tool called Waka. And Waka is a utility, open source utility, that allows an attacker or anybody to capture video off the webcam. So again, this malware shipped with a utility that the attacker could execute via the PHP backdoor to record the user via their webcam. It's pretty easy to remove Eleanor from an infected computer. You basically just delete the launch agents and the launch agentplists, and then the computer has been essentially disinfected. Okay, the next sample is Kidnap. This was discovered in July by ESET. It's a fairly standard backdoor, though it has an interesting propensity for stealing credentials from the keychain. Its initial infection vector was not known. The analyst at the time wasn't sure how it got onto Mac computers. But as the quote said, it's probably via email or perhaps social engineering. What was known, though, was distributed as a zip file. And if you unzipped the zip archive, it contained a single file, which was screenshot.jpg. Now, if we look closely, though, at that name, it's actually screenshot.jpg space. And what that space at the end does, it means when the user double-clicks it, they might think they're opening an image, but instead of opening it in an image program such as Preview, it will actually execute it via the terminal. So it turns out that wasn't really an image, it was an executable, and when the user clicks it, they would infect themselves with Kidnap. Later, another infection vector was discovered, and it turned out it was essentially the same one that the piece of ransomware we talked about was distributed. The malware authors, probably the same guys or related to the same guys, hacked the transmission website again and modified the BitTorrent application, and this time injected Kidnap into the application. So again, when users went to download transmission, instead of getting a BitTorrent application, they would get a BitTorrent application and this piece of malware. If we decompile the malicious malware binary that was injected into the legitimate transmission application, we can see it installing two launch agents. If we use a tool such as Knock Knock, which shows you what is persisted on your computer, we can see both of these launch agents showing up, and they both are named iCloud something. Again, this is probably just so that the attackers kind of blend into the noise of other Apple utilities. If we look at the p-lists for each of these pieces of the malware, we can see that they have this run at load key set to true. And as I mentioned, if you specify that run at load key set to true, the operating system will automatically execute whatever you specify. So let's take a closer look at these two binaries now. So the first binary is called iCloud syncd, and this is the main backdoor component of the malware. And if we reverse engineer it, we can see what features it has. So one neat feature is it can download and execute Python scripts, so that's kind of a cool feature to have in a piece of malware. It also is able to escalate its privileges, although it does it in a very non-elegant way. It basically just pops up an authentication prompt asking the user for their password, and if the user falls for this and provides their password, then the malware will be able to execute at higher privileges. Coolest thing though is it has the ability to dump the keychain, and it does this using an open source utility called keychain dump that's been compiled into the application. So this way the malware is able to grab everything that's in the keychain, which is probably passwords and other sensitive pieces of information. The second launch agent executes a binary called iCloud proc, and this binary is simply a copy of the Tor2Web proxy. So Tor2Web is a project that allows access to Tor services via the internet without having to use, for example, the Tor browser. So what happens is the main backdoor component, the one we just talked about on the previous slide, will connect to this component, and then it'll be able to connect out via Tor. So this is basically the malware's command and control mechanism that it does via Tor. If you want to remove Kidnap from an infected system, again, pretty easy. You just unload the launch agents, and then this will kill those processes. And then you delete both the binaries and the 2P list files that they create. And then word of advice from Thomas Reed, who's a great malware analyst, basically saying, hey, look, this is the second time this transmission application has got hacked and Trojanized, so like maybe stop using that, unless you're maybe looking for new malware. All right, the next piece of malware is a piece of adware called Fake File Opener. It was discovered at the end of last summer by Malwarebytes, and it's pretty boring, except it has a rather interesting persistence mechanism. So Fake File Opener is installed with other pieces of Mac malware when a user is tricked into believing a fake security pop-up or an alert. So this one was distributed via advancedmaccleaner.com. So if you browse that site, it would pop up and say, oh my God, your computer's infected. Please download and run this application to, clean your system. And, invariably there's some percentage of users that are going to fall for this, unfortunately. And if they fall for this, download the application and then run it, they will have infected themselves with Fake File Opener. As I mentioned, the persistence mechanism was kind of interesting, and there was a quote from Thomas saying that, hey, when he detected this malware and executed it, it didn't persist in any common ways. What it does do is it registers itself as a document handler for about 200 different types of files. And what this means is if the user at a later time goes to open a file of an extension that the malware has registered for example, .7zip or something a little more esoteric, that the operating system will automatically execute the malware because the malware has registered itself as a document handler. Now, the malware can't hijack existing document handlers, so it can't, for example, register itself as a handler for, say, PNG images or documents. But again, it chooses all these kind of esoteric files, and eventually, when the user tries to open one of those, the malware will get executed. So kind of a neat technique. So once the malware has been executed, what does it actually do? Well, all it does is goes and downloads more adware, which is really kind of lame. So it'll pop up this application that says, no application is available to execute this. And this is made to look like an Apple prompt, but in reality, this is the malware. And then if the user clicks search web, it'll take it to a website, macfileopener.org, and that website will try to get the user to install more adware. So, kind of lame and annoying. To disinfect yourself, you simply delete the application binary. Behind the scenes, this will unregister all the document handlers. And this malware is generally associated with other adware, so it's wise to check to see if you have any of those other applications installed on your system as well. And if so, delete them. All right, the last two specimens. MacOs was found in September by Kaspersky. And it's a fairly standard backdoor, but did have some rather interesting features. In terms of its infection vector, it's currently unknown how it got on end user systems. Kaspersky detected the malware, but not the infection vector. But if other Mac malware is an indicator, it's probably via some sort of social engineering, maybe emails with attachments, or possibly exploits. Now, as we've seen, launch agents are the most common way that Mac malware persists, and MacOs conforms to this trend by, yes, persisting as the launch agent. And if we actually look at the application binary of the malware, we can see there's the template for the launch agent they create. And then once the launch agent is created, if we dump or enumerate persisted processes, again, we can see that there is a new malicious launch agent that's been created. As I mentioned, the malware is decently interesting because it has some kind of neat features. It supports the standard download and execute other commands or files. It has some interesting search capabilities to look for a variety of Office documents. Can capture screen, audio, and video, which is kind of interesting, not that common in Mac malware. And then it also monitors for removable media. So if someone plugs in a USB stick on an infected host, the malware can enumerate that and perhaps grab or exfiltrate interesting documents off that. So yeah, definitely a very feature-complete piece of malware. In terms of disinfection, this is a little complicated just because the malware can register or install itself using a handful of names. What you can do though is just look for any of these names, and then once you find the one that matches, you can just delete the binary and delete the plist. Again, it's a standalone piece of malware. All right, so the last piece of malware from 2016 is called Complex. We all know Russian cyber operations are kind of a hot news topic, and a lot of Mac malware analysts believe that Complex is tied to the Russians. I think it's like APT 128. Yeah. Basically, it's one of their Mac implants or backdoors. It was distributed via an application, so a targeted user would get an email with an attachment, and the attachment would be an actual application, really not a very sophisticated infection vector. If the user was tricked into running the application, it would do two things. First, it would load a PDF document so that the user who thought they were opening a PDF wouldn't be that suspicious. But behind the scenes, it would actually install the malware. So we have a snippet of the code, and we can see what it's doing is it's actually executing the malware. One kind of funny thing is that set file command it uses is only available on developer boxes. So if you execute this on a user who doesn't have, say, Xcode installed, there's a big pop-up saying, like, set file not found. So it looks like the malware authors only tested their malware on their boxes, which had developer tools installed. So if you're writing malware, make sure you test it. In terms of persistence, again, uses a launch agent, really nothing too surprising or sophisticated here. And basically, it persists and executes a file called kexd, which is the malware. Implements a few very basic features. Can download other files, it can delete other files, it can configure the backdoor, and it was assumed that this was kind of a stage 1 implant. So a lot of nation states will write multi-staged kind of malware. So stage 1 will be very unsophisticated. It'll just allow them to enumerate the target and see if it's an interesting one, and then what they'll do is install a more advanced piece of malware on the targets that are interesting. And this is what actually happened earlier in 2017. The more sophisticated implant, the stage 2 implant that this one would likely download was discovered. So again, this was likely just the first stage Russian Mac malware. In terms of uninstalling, since it runs as a standalone launch agent, again, just unload the launch agent and delete it. But again, this is a good example of why it's good to completely wipe your system, because if you were of interest to the Russians, they might have installed a more sophisticated backdoor. So if you just delete this, there might be a way onto your system. All right, so that was Mac malware specimens from 2016. And since we have about 5 minutes left, I briefly want to talk about generic detections. And you might be wondering, why are we going to talk about generic detections? Well, I think we're all aware of the limitations of traditional antivirus. They're generally signature-based, especially on macOS. Windows AV products are actually, decent. They have heuristics and whatnot, but there's really not the same parity on macOS. So because of this, most Mac antivirus products cannot detect new Mac malware samples. For example, all the ones we talked about. If you don't believe me, just look at the next time a Mac malware specimen is discovered, a new one, hop on something like VirusTotal, which has all the AV engines, and you'll see that probably 0 antivirus engines detect it, or maybe 1, which is generally the company that detected it that reactively pushed out signatures for it. So I think we should at least discuss generic detections, because this is what I want on my Mac protecting me. So the first observation is that essentially all Mac malware persists, because otherwise, if it doesn't persist, you can just reboot your computer, and then you'll have been disinfected. So again, persistence is the way that Mac malware ensures that it's re-executed every time the system is rebooted. So I wrote 2 free tools. The first one is called Knock Knock, and it's basically auto runs, but on Mac. So auto runs on Windows shows you everything that's set to automatically start on your computer. Knock Knock tries to do the same thing on Mac. So it'll show you, for example, all launch agents, login items, kernel extensions, etc. Now, it doesn't say what is malware versus not, but that's up to you to kind of say, hey, look, this is an unsigned launch agent that I don't recognize, and then take a closer look at it. Second free tool I wrote is called Block, and what it does is it actually monitors these persistence locations. And then anytime something goes to persist itself, you get a pop-up. So it's kind of like a firewall for persistence locations. And obviously, if you're running an installer, that's fine. Something probably is going to be persisting. But if you're browsing the web or opening a Word document and all of a sudden it creates a new cron job or launch agent, that's a pretty good indicator that you might have just been exploited. Another observation or generic detection I think we should be able to flag or detect is ransomware. So let's make the kind of obvious observation that ransomware creates many encrypted files, often in a rapid manner. So I wrote a simple utility that continually monitors the file system, and what it does is it looks for the rapid creation of encrypted files by untrusted processes. And if it sees this occurring, it suspends the process and pops up an alert to the user saying, hey, there's this process that's creating all these encrypted files. And it's a little reactive because there might be 2 or 3 files that are encrypted, but currently it's able to generically detect all Mac ransomware. So kind of neat. Finally, and I'm going to be talking about this a little more in depth tomorrow, we've seen a variety of Mac malware specimens that will spy on the user via the webcam or the mic. And yes, the webcam LED will go on if the malware is recording you, but there's some cool attacks where malware can piggyback onto legitimate webcam sessions to surreptitiously record the user. And if a piece of malware is hot micing your computer using the mic to record what you're saying, unfortunately there's no alerts for that. So again, I wrote another free utility that just monitors the mic and the webcam, and if anything tries to access that, it just pops up to tell you what is accessing that. So yeah, those tools that I just mentioned and some others are available on my Mac Security website. It's all free, so I hope this doesn't sound like a sales pitch. Also, all the malware specimens I talked about are available for download as well. I also blog a lot about zero-day vulnerabilities in the Mac kernel. New malware samples come out. So if you're interested in Mac malware or Mac security, just check it out. All right, so that is pretty much a wrap. Just to reiterate what we covered, we talked about all the malware specimens that infected Mac, new malware specimens that we saw in 2016. And what can we do? Obviously, it's good to stay updated, stop opening random emails from the Russians, and I think it's a good idea to install some tools that provide generic detections. So we have about a minute or 2 left. If there's any questions, I will gladly answer those, and if I get kicked out, I will be right outside and we can chat some more.
Anybody question for Patrick? Yes.
Hi. So you have some really good tools. Did you plan to do like one really good security tool for macOS? Because for us users, because I want to install 5 of them now, and why not to be just one really good tool that does everything?
That's a great question. So I will caveat that I'm a security researcher foremost and a enterprise-minded business software engineer second. So I would love to combine these into one tool. So that's definitely in the works. That's a plan. But yeah, currently they're all individual, and I agree. I run like 3 or 4 of these, and I'm like, okay, this is silly. So yeah, that would be the ideal, and that's something I really want to work on. Kind of having a single product that kind of has maybe a plugin-based architecture that you could select what features you want. So great question.
So any VCs that are here could then later.
No, it's all free.
Okay. We've got time for one last question. Anybody? No? Then I would like to thank Patrick very much for his presentation.
Thank you.